Chapter 7, Section 1 is entitled Frequency Tables, Stem and Leaf Plots, and Line Plots. Our objective here today is to organize and interpret data in frequency tables, stem and leaf plots, and line plots. We'll start off and look at the vocabulary we'll be using throughout this lesson, and those terms are as follows. We've got frequency table, cumulative frequency, stem and leaf plot, and line plot. A frequency table is a table that organizes data into categories or groups. A table that organizes data into categories or groups. Cumulative frequency is a running total of the number of data items. A running total of the number of data items. A stem and leaf plot is a graph that uses digits to organize and display a set of data. A graph that uses digits to organize and display a set of data. And a line plot is a graph that shows how many times each data value occurs. So now that we've covered the vocabulary, let's go ahead and look at the different examples that will involve this vocabulary. We'll start with the first example. It says the list shows the average high temperatures for 20 cities on one February day. We're supposed to make a cumulative frequency table of the data, and then we're asked how many cities had average high temperatures below 59 degrees. So we have to make the table and then answer the related questions. So what you're going to do here is you're going to look at the range to choose equal intervals for the data. One of the things that a frequency table involves is creating equal sized groups that you arrange your numbers into. Once you do that, you're going to find the number of data values in each interval, and we'll write those numbers in the frequency column. And you'll see a slight variation on this, and then I'll show you the more proper way. And then we'll find the cumulative frequency for each row by adding all the frequency values that are above or in that row. So, as we continue on here, as you can see, the very first thing I did is I put the numbers in order from least to greatest. Now actually, as you can see, the numbers as listed were in order from biggest to smallest. Usually you'll see me when we do a problem like this, or maybe a mean, median, mode, and range question, is we'll be putting the numbers in order from least to greatest. The box set up at the bottom is how a frequency table is going to set up. What you're going to do in this first column, where it says average highs, and you would label this appropriately for the question you might be given, is you're going to set up even-sized intervals of numbers that involve the numbers in your question. What size interval you choose is completely up to you as you go through the creation process, as long as they're even sized. So as we look at what we're doing here in this problem, we're going to see that the groups are going to set up from 0 to 19, 20 to 39, 40 to 59, and 60 to 79. Notice all those are group sizes of 20. There's 20 numbers in each set. And again, you can pick whatever size you want, but you have to have the same size group in each category. Now, in this particular question, one of the reasons that was chosen is because it's asking about the temperatures below 59 degrees. So as you can see, we have categories set up such that those numbers will not set up to hit that 59 and show the numbers below, which will make this answering the question much simpler. Okay, so now what we have to do is we're going to go through and tally mark out where each one of the numbers belongs. So for instance, this first number in the list, 2, is going to cause us to put a tally mark here next to 0 to 19 because it's in the 0 to 19 range. Then we have another 2, so another tally mark there. And then 4, so another tally mark. And we'll go through and we'll repeat that process the whole way through. As you can see, what I've just shown up on the screen with the different colors separating the numbers is how the numbers will break out into the different categories. So as you're going to see here, we're going to end up with 4, 5, 6, 7 numbers in this 0 to 19 group. And then we're going to end up with 5 numbers in this 20 to 39 group, and so on down the list. So as you can see, the tally marks are generating. And out in the right side column, we're just showing the total number of tally marks there. So as you can see, we made 7 tally marks, so we wrote a 7. And we go through and we repeat that process for each group. Now, what the book does that's slightly different than this is instead of listing tally marks and then the frequencies, is in the middle column there where it says tally, they would actually just simply write the number. So they would actually put the 7 and the 5 and the 5 and the 3 there. And then what they would do going down this right column is they would sum that row with the numbers above it. So yes, they would write a 7 here, but in the next one, they would actually end up writing 12 because this one and this one, when I add it up, makes 12. And then in the next box, they would write 17 instead because that row and the numbers above it add to 17, which of course means that the last one is going to be 20. As far as answering the question then, what we would do is when we're talking about the number of temperatures less than 59 degrees, is we're counting up the numbers from that category on down back towards 0. So we already did that when we figured our frequency when we figured 17, meaning 17 cities had average high temperatures below 59 degrees. Question number 2 says the data shows the number of years coached by the top 15 leaders in all-time NFL coaching victories. And we are to make a stem and leaf plot of the data, and then we're supposed to find the number of coaches who coached fewer than 25 years. And as you can see, the numbers are listed there. So again, as we did with the earlier example, as you see at the very bottom of the screen, I put the numbers in order from least to greatest for us, which just makes our task a little bit simpler. So in step 1, it's asking us to find the least data value and the greatest data value, which are 15 and 40 respectively. And we're going to put the tens digits in the stem of this stem and leaf plot, and the ones digits are going to go in the leaves of the stem and leaf plot. We're going to list the stems from least to greatest on the plot, and then list the leaves for each stem from least to greatest. So let's take a look at how this is created, which is what we'll see on the next slide here. As you can see at the top of this slide here, I've got once again listed those numbers in order from least to greatest, which just causes me not to have to flip back and forth. What you do in creating a stem and leaf plot is you put what I call the most consistent data to the left of a bar, and that's called the stem of the stem and leaf plot. What's consistent about this set of numbers, and what's actually pretty easy when you're looking at a 2-digit number, is that they all start in this particular case with a 1, 2, a 3, or a 4. So that's going to go in the stem of the stem and leaf plot. What you do then is you take the ones digits that corresponds with the tens digits and write them over here to the right of the bar in what they call the leaf area, the leaves. So for instance, the first number on my list here being 15, next to my 1 I'm going to put a 5, and those are going to represent 15. As I said, what's very convenient about this, when it's a 2-digit number, you have no choices. The first digit's almost always going to have to go in the stem, and the second number is almost always going to be in the leaf area. When you have a 3-digit number, you have to make a choice. For instance, if the numbers are like 100 and 110 and 120, you have to decide, is them all starting with 1 going to be what I'm going to put in the stem, or perhaps that I'm going to look at they all start with 10, 11, and 12. Is that what I'm going to put in the stem, and then just put that last digit in the leaf area. One thing that you have to note here in the stem area, once you figure out what your starting and ending number is, you can't skip any numbers. So let's just say there was a 70 on the list, which really wouldn't make sense in context of the problem, but it's good for explanation. If there was a 70 on the list, we would have a 7 and a 0 that would match this stem and leaf plot. I can't skip 5 and 6 though in the stem, even though there were no numbers that would match it. I would still have to write 5, 6, and then the 7 for my 70, but there would be no numbers in the leaf area over the leaves. So we go through all the numbers and we match up where they fit. Now what we've actually created here, because I put the numbers in order, is called a ordered stem and leaf plot. There is also an unordered stem and leaf plot. It would in essence be the same thing, but the leaf numbers do not have to be in numerical order. As you can see, for instance, the one row here goes 5, 5, 5, 8, 9, which is in order from least to greatest. That is not necessary in an unordered stem and leaf plot. Once we've made our plot, we add a key and a title, the stems being the tens digits and the leaves being the ones digits. And the key down here simply shows us how the numbers are to be interpreted or read. again, as we talked about several times throughout this example, it doesn't necessarily just have to be a 2-digit number. It can be a 3-digit number, a 4-digit number, a 5-digit number. It could even be 2 numbers, but perhaps represent a decimal. For instance, 1 bar 5 could represent 1.5. So the key tells us what the numbers would really mean. And of course, the idea behind that is we wouldn't have the list of numbers, so we wouldn't know what it means except for having looked at the stem and leaf plot. So then the question is, how many coaches coached for fewer than 25 years? Well, as you can see, it's easy. We just count the corresponding leaves now. And as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 that come under the 25 mark. Notice I'm not counting this one because this would actually represent 29. And of course, the question is asking me how many coached fewer than 25 years. Now we're supposed to make a line plot of the data in number 3. And as you can see, we've got quite a table of numbers there. And it's about the number of hours per day Morgan is babysitting. And we're going to make a line plot of that. A line plot is very simple. It starts off with a number line. So since my smallest number is 0 and my largest number is 8, I'm going to make a number line that goes from 0 to 8. And all you do is pretty simple. Once you make that number line, you put X's over the number that matches the number from the table. As the directions say, we're going to put an X above the number on the number line that corresponds to the number of miles, I should say the number of hours, Morgan babysat each day. So, for instance, in this first box here it says 0. So I'm going to go above the 0 and put an X. And then the next one says 6, so I'm going to go to the 6 and above it put an X. And I'll repeat that process for every number in the table. Since the question is asking us about how often she babysat, and specifically the greatest number of hours she babysits most often, in this case, we're simply looking for the tallest bar of X's. And the tallest bar of X's is above the 6. So that means Morgan babysat for 6 hours more often than any other time frame. Okay, so let's do a little practice together now. It says that the list shows the grades received on an English exam, and we're supposed to make a cumulative frequency table of the data. How many students received a grade of 79 or below? So remember, what's important about making a frequency table is even-sized groups. Notice the groups I've set up represent the different score ranges, the D's, the C's, the B's, and the A's. So I've got 60 to 69, 70 to 79, 80 to 89, and 90 to 99. And notice those all represent groups of 10 numbers. One of the things that you probably caught on to is that these first set of numbers here all end in 0, and the second set of numbers here all end in 9. That's actually a very simple way to keep track of the different groups. Okay, so then as you can see at the bottom of the screen, the numbers are in order. So I went through and put tally marks to represent each number in the system. So I've got 60 to 68, 4 numbers there. That's why there's 4 tally marks next to 60 to 69. And then I've got 4 numbers in the 70s from 71 to 79. So 4 tally marks there. And on down the list I go. 4 tally marks in the first group, 4 tally marks in the second group, 6 tally marks in the third group, and 6 tally marks in the last group. If you wanted to do a cumulative frequency table, which is what they're going to ask you to do in the homework, remember the differences from what you see on the screen is over here I'm going to have these numbers instead, my 4 and 4 and 6 and 6, and then what I'm going to have over here is a summation instead. So yes, this first one will still be 4, but the second one would instead say 8, because this box and this box adds up to 8. This box would be 14 because 8 and 6 go together to make 14, and this final box would be 20. Remember, then we do have a question to answer, and it says how many students received a grade of 79 or below. Well, as you can see from the cumulative frequency table aspect, there was 8 when we got to the 79 number, so 8 is my answer to the question.